Hello, this is Mr. Knight, Geometry Chapter 1.6, Classifying Polygons. So let's go over a few vocabulary here. We're going to talk about what actually is a polygon. So if you look at your key concept little block there, a polygon is a closed plane figure. That just means a two-dimensional flat figure with the following properties. And your properties are critical here. We have two properties. One is it is formed by three or more line segments called sides. Line segments, as we know, are straight. Okay, they are not curved. So a polygon, in order to be classified as a polygon, it must have straight sides, straight line segments, three or more. So triangle, something triangle or greater. And then the second requirement or property is that each side intersects exactly two sides, one at each endpoint. To kind of re-clarify that, it's given any type of figure. If I have more than two line segments that intersect at a vertex, and it is not a polygon. So that's another way to state that, right? So vertex is just the intersection of two line segments, okay? So all of those are vertexes, if you will, all right? So now we have, when we talk about polygons, we talk about concave and convex, and it's convex is pretty simple. It's just, where's my, there you go. Convex is, when I look at all sides, no two of the sides are protruding inward or outward from the figure itself. And what I mean by that, when I look at concave, I have a protrusion inward like a cave. If you think of the word cave itself, it's like a hole in the ground, right? So when I look at, sorry about that, we had some music over the intercom. All right, so back to this, concave and convex. All right, a convex polygon is two sides that would protrude inward. And if you kind of think of the word cave itself, the word cave itself is like a hole in the ground. So when you're looking at a polygon, if I have any two sides that protrude to the interior of my polygon, then it's called concave. If I don't, then it's called convex. And I apologize for that video, for the sound that's in the background, but I can't do anything about it. All right, so identify polygon. So we want to know, is it a polygon and whether it's convex or concave? I know that that is not a polygon because I have three line segments that intersect at a vertex. I know that that is a polygon and it is convex. That is neither because of that curved side. Remember, one of the properties of polygon is that it has to be a line segment, a straight line. This is a polygon, and because of this right here, because it's intruding into the interior of my polygon, this would be a concave, okay? All right, sorry about the music. All right, let's see what's next. Classifying polygons. We call it n-gon. N just represents the number of sides, all right? If it's three sides, it's a triangle. Four sides, it's quadrilateral. Five sides, it's a pentagon. Six sides, it's hexagon. Seven is heptagon. Eight is octagon, and so forth. All right. Now we have polygons. We know that they can be concave or convex. Polygons can be equilateral. Polygons can be equiangular, and there's a special type of polygon which we call regular. An equilateral polygon means that all sides are equal on my polygon. Equiangular is all angles are equal in my polygon. And then to be a regular polygon, there are three requirements, three properties. My polygon needs to be equilateral, my polygon needs to be equiangular, and my polygon needs to be convex. So this right here is an example of a regular pentagon. The three requirements, it is convex, it's equiangular, and it's equilateral. Therefore, I can classify this as a regular pentagon. So if you're reading a problem and it tells you that your polygon is regular, that tells you information right there, okay? So I think we have one more, no, maybe two more slides. So it says classify the polygon by the number of sides, okay, and tell whether the polygon is equilateral, equiangular, or regular, all right? So we have 1, 2, 3, 4, 5, 6, so we know that that's a hexagon. I know that it is convex, I know that it is equilateral, and I know that it's equiangular. So therefore, this is a regular, just R, polygon, RP, regular polygon. All right, if I look at this other one, it is convex. It is not equal angular because that and that angle are not equivalent. And I know that that side and that side is not equivalent, therefore it's not equilateral, so it's just and it's convex, so it's just a convex polygon. So if I look at this right here, it is a polygon. It is equilateral because all the sides are equal. It is equiangular, okay, because all the angles are equal to each other, but it is concave. It is not convex. It's concave because these angles, these sides right here are protruding to the interior of my polygon. So it is just a concave polygon. It is equiangular and equilateral, but just concave. It's not regular. So I think we have one more. Yes. All right, here's an actual problem. It says a table is shaped like a regular hexagon. That's key right there, regular. I know by definition prior to the previous page that regular means that my polygon is equilateral. If it's equilateral, those two sides are equal to each other. So then it says the expression shown represents side lengths of the hexagonal table. Find the length of a side. All right. Since I have a variable, I'm going to have to find the x value first, plug it back in, and actually find the side length. So I know that 3x plus 6 is equal to 4x minus 2, right? So let's get rid of the x's. That's x on the right. Let's bring the constant over there. That's 2. So I know that x is equal to 8. Now let's figure out what the length of one of these sides. So I'm going to do, actually I'm going to work over here. I'm going to do 3 times the value of x, which is 8, plus the 6. That's 24, plus the 6, and that gives me 30, and our units are in inches. So I know one of these sides is 30 inches. If you want to double check yourself, plug x into this value. 4 times the value of x, which is 8, minus 2, that's 32, minus 2, and all that gives me 30, and it's 30 inches. So I know that my answer is correct, okay? So that concludes 1.6, classifying polygons. Have an awesome day, and we'll see you tomorrow.